Hey guys, in today's video we're going to be checking out the Artillery Sidewinder X2. So I'm really excited for this printer because I really like the X1. So in this video we're going to unbox it, set it up, and do some prints. Hopefully you guys enjoy the video. Let's get started. Alright guys, so this is the box that the Sidewinder X2 comes in. And here we can see the size of the box, which is 668 by 508 by 310 millimeters. And on the shipping label it says 35 pounds. Alright, so let's go ahead and open the box. So we can see right on top we got soft foam, very nice. And here we can see how everything is laid out. So it looks like we have the gantry here, the upper portion on top. Looks like this middle part comes out. And actually inside here we have the manual, and it appears very nice and well laid out with step-by-step instructions and then how to use the machine itself. So yeah, very nice. And here's a little glimpse of all the parameters. All right, so we also get a little pouch here. It says Artillery on it, the little zipper, and looks like we have tools and extra things in there, and we'll go through this in a second. The spool holder, looks like it is top mount, and the filament detector is already attached to it. All right, and yeah, the foam is nice and thick and everything is well protected. So let's see if we get this upper portion out. So as you guys can see, everything is pre-assembled. We have dual motors, very nice. And what's even nicer, or maybe just as important, is that we are synced here, or synchronized on the top with this belt here. So we're gonna take a closer look at all the details here in a bit, because it does look quite interesting. All right, so here looks like I missed the power cord, which is the US type. More foam, even more foam. And on the bottom there, we have the base, which is very well protected. I mean, there's a lot of foam. So yeah, that's nice to see that they got it nicely packed. Let's see if we can't pull it out of there. Got a little bit of weight to it, but yeah, right off the bat, looking really nice. And the first thing that really stands out is how thin this whole profile is. So yeah, that's it for the box. Let's go ahead and flip this thing around. I guess we'll put it long ways. And so what I want to do is take the bottom cover off so we can look at what's inside. And there is a void warranty sticker there. So yeah, I'm not sure how valid that would be, but so let's quickly go through this baggie. So there's a few things in here. So first of all, this part came out. It was, I think, like this. So this looks like part of the spool holder. This is where the spool is going to roll on, and it's kind of like a bearing there. So yeah, very interesting. So we got a baggie of Allen wrenches and some little bolts in there. An open-ended wrench, 8 and 10 millimeter. It looks like an extra ribbon cable. Yep, it is. If there's any issues, you do have an extra one. It looks like another roller here, the same kind that we saw earlier. Here we have some extra parts, wheels, some zip ties, an extra nozzle, and our thumb drive, which is 16 gigs, and it's Artillery branded. And for the last part, we have a USB cable that connects from the printer to your computer. All right, so let's grab an Allen wrench, and there looks like to be 6 little bolts here around. Not sure if these feet have anything in them, but we'll see in a second here. All right, so all the little bolts are out, and I went ahead and cut the warranty label, and it does appear that the cover just comes right off. So just the little 6 bolts holding it. And there is a fan that's attached. Let's go ahead and disconnect it from the board. And you guys can see it's a pretty nice fan. Good size. And the 4 feet are made out of plastic, but they're kind of like a soft plastic. So all right, so yeah, as you can see guys, it's very nicely laid out. Let's start here at the back. So we have the power socket. There's the inlet. It is fused with an on and off switch. So all the power wires are routed nicely to the power supply. Now if you guys notice, it's a smaller one and it looks like it's a 200 watt, 24 volt, 8.5 amp. And the reason it's this small is because its only job is to run the hot end and the electronics. So if we go back to our power distribution here, we can see that the AC lines go here, but they also, you can see there's two wires, go to this little relay here, which looks to be solid state. And this actually runs to the bed. So this printer has an AC heating bed, which is really awesome. And this is why you don't need a huge power supply. And also in this solid state relay, we have the adjustment to the voltage depending on where you live. So it serves two purposes. So also in the back here, we can see a stepper motor, and this is our Y axis. If we pull back here a bit, you can see there's a frame going all around. So not only is the shell or the outer casing is all metal, but we also have a frame inside. Also a nice detail is how the wires are all routed through and they're protected with these little covers. So they're not in danger of shorting out. Great attention to detail there. So going over here, we can see the main board. It is artillery branded, called Ruby version 1.2. It does have an ARM processor. And also you guys can see we have removable stepper drivers. So let's go ahead and take one out and look at it. So I don't really see what kind they are, but they are the silent drivers and look to be very nicely built. Put that back. And another detail, you guys can probably see that everything is glued, I guess kind of like hot glue or something. So none of the connectors pop off. So yeah, that's really nice to see. And going over here, we can see we got the display board, and right next to it is the reader, the micro and USB. So yeah guys, overall pretty impressed with how everything's put together. So I'm gonna put the lid back on and we'll flip it around and start the assembly. All right, so we're flipped back around, and before we go into the manual and start building this thing, I wanna go ahead and adjust the bed here. So the bed rides on this rail here. Maybe you guys can see there's 3 rollers on each side. So the rollers are going around the channel or the rail. So there's 3 stationary rollers and 3 adjustables. And this is where you're gonna need the wrench here that was included. And so you guys can see the adjustable ones there. And so all it is a nut with an eccentric kind of hole. So whenever you spin it, it like wobbles around like this. So it gets farther and closer away from the channel as you spin it around. And so what you wanna do is you wanna stick your hand in there. It's kind of deep in there, but you just wanna see if you can roll the roller. And on mine, they're all way too tight, like so tight that whenever I move the bed, it actually kind of jumps around because it's too tight. So I need to loosen them a little bit. So depending how yours came, it's going to be, you know, too loose, too tight, or maybe it could be perfect. So ultimately what you want is the roller to easily spin with your hand when you spin it. Well, not easily, but with some friction, and at the same time have no wobble. So you want it as loose as possible, but tight enough where this doesn't wobble. So yeah, and it is a little bit hard to get to them, honestly, because the bed is kind of wide, but technically not impossible. So okay, so the first one is good, and I'm going just a little bit on all of them. I don't know if you guys can see, but I am spinning the wheel. Okay, so that feels good. So I can spin all of them with my finger. So yeah, we have no wobble in the plate at all, so we're still good there. So yeah, that feels 1,000 times better. But yeah, that's basically how you adjust the wheels, and you definitely want to make sure you check that, because you don't want to run the printer with over tighten or, you know, even under tighten. The bed will wobble around and that could be an issue while you're printing. And also guys, while we're doing this anyway, you can also check your belts to make sure they're running true on the pulley, because if they're not, which mine looks fine, you can adjust it so you can bring it up a little or down a little. And also on this idler pulley, it's not adjustable, but you can also check it. Mine looks fine too. So all these things are, you know, somewhat important, because if everything's adjusted well, it'll all work well together and you'll have good print quality. All right, so let's get to the manual. We can see everything that's included, and there's not too many parts. So putting this thing together should be quite simple. So for step 1, we got to put the main gantry, which is the upper portion of the printer, onto the base. And here it shows you kind of how it goes. And the bottom picture there shows you that underneath. And here you can see the slots where the gantry will sit in. There are bolts already that are kind of pre-mounted there, and they go through, and that's what's going to connect it. So let's go ahead and grab that. So yeah, it's just going to sit right here into the slots. It's going to kind of fall in there, just like that. We'll grab our included Allen wrench, and now we can either pick it up with our hand, run the bolts in, or you can just kind of go off the edge of the table. You don't have to lift it. Or better yet, you can grab something and put it underneath the printer, and that'll hold it. So yeah, not very hard guys. So we're gonna run these 2 main bolts all the way up, but I'm not gonna tighten it yet. I'm just gonna snug them a little bit. All right, same thing here. All right, so now we can go ahead and tighten them up really good. And make sure you do that because we do have a really short wrench, so there's not much leverage. Definitely snug it up nicely, because these two bolts are the only thing that's holding it. There's no other bracing. And actually guys, I just realized something that was probably quite important, that because we started with the other side, I didn't even notice, but we did have a plug that automatically just kind of fits in where it goes right there. So yeah, that looks fine. So make sure when you're putting it in that, you know, that plug is plugging in, but there's no other way to put it in. So no matter how you do it, it's gonna, you know, connect to the other end. But yeah, maybe be a little more cautious than I was. All right, so this side's pretty tight. Let's go back to the other side and tighten those up. But to be honest, I wish there was a little bit more bracing, maybe some bolts here through the side that go into the channel also. But yeah, it looks like they're okay with just 4 bolts there, and there we go. So far guys, this is not very hard installation. So we got our main gantry on and it seems to be pretty good. Yeah, let's move to the next step, which is the spool holder. And we can see here how it goes together, and then it goes on top. It looks like mounts with just one little knob there. All right, so let's grab our brackets. You guys can see that one of them has that knob. So they come together like this, but they need to be the opposite with the filament detector on the inside. And so these things here will go in between the frames like this. And in the baggie of the Allen wrenches are the 4 bolts that we need. You guys can see the inserts have threads in it. We're gonna grab a bolt, put it through the hole, and then we'll screw it into the metal part just like that. And I guess we can take these off for now. But yeah, we got one piece there and the other one will go here. So you do have a couple options, I guess, if you have smaller spools maybe, but they do show here just like that. Now we're going to put the sleeves back on, and then we'll grab the other side, put it on top of that, and then the 2 bolts that'll hold that. So yeah guys, they went all out and redesigned this spool holder. It's interesting to see how some companies take the time to think things through, and then others just kind of slap a piece of plastic and you roll on that. So this is kind of like a smooth roll here because it's metal on plastic, but it feels like it's almost like bearings. But there's ever so slightly some friction, which is also good because when you have retractions or just movements when the nozzle moves around, you know, it could sometimes jerk the filament, where if it rolls too easy, it'll just roll right out. So all right, hopefully you guys can see that pretty well. But yeah, there's some slots here. I'm gonna unscrew this knob completely, take it out, and then it's literally gonna just sit right into the slot here right in the middle. So, and what's interesting is actually it's not adjustable here. So I guess this is a permanent mount. So anywhere you go is a permanent mount. So yeah, I guess we'll go in the middle. Makes sense. And then we'll put this little knob right here, and that's gonna keep it from coming out. So it's already not sliding side to side. But yeah, we're way up here guys, and right off the bat I can tell you that there is some wobble up here. Not sure if that's a good thing, but I wish they would have made some kind of bracing. Even would have been nice to have some kind of rods from here down. So in any case, so if you guys look over here while we're up here, let's go ahead and plug in this sensor. So the wire just feeds out from the back, and we're gonna go ahead and plug this in. There we go. So yeah, for the next part guys, looks like we just need to plug everything in and then do some more adjusting. And that is it for the build, which as you guys can see was very simple. So we plugged the filament detector in, and there's actually only a few more things we need to plug in. So looking here at the back of the printer, we can see we have some plugs here. So there's a white plug that'll plug in right there. And that's actually the filament detector coming down from the top. Okay, so we got a motor plug here, which is a black plug that plugs into the motor. Just like that. And here on the other side, it's somewhat the same thing. We got the motor plug, and then we have another plug here that comes out. And as far as I can tell, it doesn't really go to anything, or at least I can't see where it goes to at the moment. So we'll leave it alone for now. But yeah, that's pretty much all the plugging in. All right, since we're back here, let's go ahead and check and adjust a few things. But there are a couple zip ties here. I'm gonna go ahead and cut them. They're holding the Z axes from going up and down to protect it during shipping. But yeah, if we turn this, we should be able to move it up and down now. So what we need to look at here are the wheels. So there's 2 here and 1 on the inside, same way on the other side. And then we got the hot end here that rolls on 3 wheels here. Definitely is too tight, and these are pretty good, maybe a little tight. And so the way you adjust this, since you can't get to it, is, I don't know if you guys can see, but there's a little set screw right there, and you're just gonna use an Allen wrench, and that's how you adjust the tension on these wheels. So depending, you know, if you want more or less, like right now I loosened it a lot and it's kind of wobbling, so maybe I'll tighten it back a bit, and that's probably good right there. So yeah, I can still spin the wheels. They're a little tough to spin, but that's okay. The point here is that, you know, you can still spin them. But yeah, that's not too bad, and pretty unique way. I've never seen it to be adjusted like this. Yeah, so that feels good right there on both of those. So let's go ahead and adjust the Direct Drive Extruder, which includes everything, including the hot end. So let's go ahead and move it up a bit. So I am too tight. I can feel it, you know, kind of bouncing around on the rail. So let's go ahead and grab our wrench and loosen the eccentric nut, which is under here. So these are stationary and this one's adjustable. And we're gonna loosen it just a bit, whatever way that is. Okay, it's this way. Okay, so that feels pretty good right there. Let's see, yep, how it rolls. Okay, much better. So because this is a direct drive and it has the extruder motor and everything in it, you know, you don't want to make this too loose. Usually I recommend, you know, making this as loose as possible. But for this one, you definitely want it pretty loose, but you want it to be firm, so not easily, you know, persuaded. Yeah, that looks good right there. So I can still spin my wheels quite easy. There is some friction to it too. So, and as it runs around back and forth, it's gonna, you know, level itself out as these wheels continue to move around back and forth. All right, well, that feels good there. And we've adjusted our bed already. So yeah, we're officially done with the assembly process. And Artillery made it very simple to put this thing together. I'm gonna go ahead and take this paper off from the bed. And we'll take a closer look at the X2. All right, so yeah, you guys can see it's a pretty tall printer and our spool holder's on the top, so it makes it even taller. And it does take quite a bit of room on the desk. So if you are wanting to get this printer, make sure you got the room for it. So let's start here on the top. We got the spool holder that we installed with these nice little rolly bearing type holders. Our filament detector, which I'm a little confused how that's gonna work since the spool sits up here. Anyways, we'll figure that out. So our top frame is plastic, which I'm not crazy about, but it is reinforced, so it is sturdy, and we have this Sidewinder imprint in it. So yeah, I mean, it looks pretty good. Personally, I think I would have just liked an aluminum frame there, but this type of design, you know, can extend here to house the lead screw with the bearing in there. So yeah, overall looks pretty good. So the side channels are normal aluminum extrusion that are, looks like 2040s. Flipping around, you guys can see the back and the synchronized lead screws with this belt. Very nice to see. Our filament detector wiring there, nicely tucked away, goes down to the channel all the way down and plugs in over there. So we got dual lead screws going all the way up, and they're quite long. So coming down to this frame piece here, I was pretty impressed to see these are actually metal. Looks like aluminum brackets, and yeah, very heavy duty and quite interesting how to adjust the inner wheel. Our brass bushings here, they have this kind of C-clamp here to keep it from going up and down, and it's the same on both sides. So going down from there, we got couplers and the stepper motors on each side. Looking down at the printer, we can see that they have this really nice, interesting, pretty tough looking cable that connects to the bed. And I like how they routed it inside. And don't forget, guys, that this is actually AC power that's coming from the plug. So yeah, this has to be protected very well. And looks like they did a great job there. We can see our very large wide channel on the Y-axis. This is the in-stop switch for the Y, and it's just like a push button. So the bed is glass, and it's got that perforated kind of texture, which when heats up should stick very well, and then when it cools, it pops right off. Also, it is insulated. You guys can see, very nice. You guys can see the frame there, and we got pretty large twisty knobs with these nice quality springs for adjustment. Looking at the very back, here we have the power input. It is fused with an on and off switch. And right beside that, we have the voltage selection switch, which you definitely want to check before you turn on your printer. So depending on where you live, you'll turn that to 110 or 220. And all the way on this side, we have the manufacturing sticker, which gives us all the details about the printer. And you guys can see that it is a 300 by 300 by 400 millimeter build volume. So flipping back to the front, we got some pretty interesting design here, which we have these nice ribbon cables. So there's one here going up and down, and so there's a distribution box in there, and it goes around next to the channel and then plugs into there, as we talked about earlier when we were putting the upper portion in. And then we got another ribbon cable that runs across and then around to the Direct Drive Extruder. So there's not too much to see here because everything is covered up. We can see the X-axis stepper motor, but if we look at the Direct Drive assembly, we can see there's quite a few interesting things here. So we have right on top the extruder knob, and this is where we're going to feed in our filament from the top, and it's going to go down into the hot end. So this whole piece here is metal, and there's kind of like a heat sink here, and the fan cools that off, and that's somehow all there together with the heat break. So yeah, we got a junction in here with also our stepper motor inside of there. We got a pretty large axial fan for the parts cooling. You guys can see our heat block there. It is volcano style, so it's vertical instead of sideways, and there is a silicone sock on it. And on this side, you guys can see we have a probe here, and this is for the out-of bed leveling. So yeah, very interesting looking Direct Drive Extruder hot end assembly, and very similar to the first X1 model. So going down to the bed, we do have an Artillery logo. It does say 110 volts, and the reason for that is because this is an AC bed and it's only made for that voltage. And on this side, we got some caution icons. All right, so going to the front of the printer, we got a nice large Artillery logo here. And on the left side, we got the screen. Let's go ahead and peel this off. So it is a smaller screen, which feels a little dated, but you know, that's okay as long as it works as good as it did before. And we also got a little reset button there. And on the top here, the USB port and the micro SD card slot. And our side is pretty clean with some venting. And on our other side, we have some venting and also our connection via USB type B. So yeah guys, really nice looking printer, and I love the low profile. You guys can see that's very thin for how large this printer is, so it looks very nice. So for the next part, let's go ahead and plug the printer in, turn it on, and level the bed. All right, so I got the printer plugged in. Let's go ahead and hit the power switch. All right, so there's a beep, logo, and it's booted up. Wow, very fast. I definitely like that. And I don't hear any noise at all. So it looks like it doesn't turn on the fans unless it's in operation. So that's nice. It's literally dead silent being on. So you guys probably can't see this very well, but I'm gonna go ahead and click on tools, and then we'll click heat, and we'll preheat it, say to 220, and then switch it to bed and go to 70, and I can hear the fans coming on, which looks like the one underneath came on, so still very quiet. All right, let's go back, and if you guys can see here, it says home. I'm gonna go ahead and click that, and we'll go ahead and home the machine and see what happens. Now it should be smart enough not to hit the bed because it does have that probe there, so I don't think we have to worry about leveling anything at this point. So let's do that. Okay, so that works. So the X and Y homed, and now the Z. You guys can see the pin came out. And there it goes. Wow. Pretty cool. So yeah, looks like all the axes are working. That's great. We're off to a very good start. So for the next part, let's go ahead and click on level here. And it's gonna give us 5 points, including the middle. And so what we're gonna do here is we're gonna level out the build plate so it's flat as it could be. So let's click on the first here. And it's gonna move to our first spot. So I'm just gonna use this piece of paper that was included. So it's gonna take a measurement there. All right. Actually guys, this paper is way too thick. I'm just gonna use a Post-it note. But yeah, we're just gonna grab the Post-it note and put it underneath the nozzle. And then we're gonna adjust the knob here until we get some kind of friction between the nozzle and the build plate. All right, that looks like we got a little bit there. So now I'm gonna go to the second position. Good right there. Third. Good right there. Fourth. And you definitely want to do this, guys, with the bed being heated, because since this is glass, when it heats, it does expand a bit. And you know, you want to be as accurate as possible because when you're printing, your bed is hot. So let's go to number 1 again here, first corner. And it looks pretty good there. It looked like it was already pretty level, so just that minor adjustment, it looks like all we needed. And we can go to the center also, which is the 5th position. And we'll check that. And that's perfect right there. So yeah. So let's go back. Okay, so if we click on more, we got outer bed leveling. So now we can do the outer level. So yeah, first you want to do the manual leveling to flatten it out. And now we're doing the outer leveling, which is going to take a lot of measurements. So it can adjust itself as it's printing. And then after it does all this, we're going to go ahead and do the Z-axis offset. And then once we do all that, we'll click the save button there to save it all. So it looks like it's finished. I would think it'd go to the middle next and let us do the offset, but it's not going anywhere. So maybe I need to click on something here. So let's click on this. Okay, well, let's go ahead and save that, whatever it did. So I'm going to click here on the EEPROM save. And I'm guessing that saved it. So let's go back, click on level again, and go to the center, which is the 5th. All right, so yeah, we're definitely too tight. So now we need to go back more and then go up with the baby steps. So, oh, that's the wrong way. There we go. So yeah, this is how we're gonna adjust our gap between the bed and the nozzle. So once you're happy with that, we're gonna click on the EEPROM save. And that should save it, and we should be done technically. So go back. I'm gonna go ahead and home it again real quick. All right, so let's go ahead and look at the menu real quick. Let's go back here. So yeah, this is how it starts. So we can see this is our nozzle temperature, our bed temperature, and then our fan. We got tools, set, and print. So if we click on tools, this is where we get our main menu for heating, and you can select the bed and the extruder here, and then the amount that you can go each time. So right now it's on every 10 degrees. So if we go down, we'll go to 60. The extruder, this is where we can control the extruder in and out. So this is not really necessary for this printer because it's a direct drive. It's much easier just to manually do it. Move, you can move our individual axes. Then the home button, you guys saw earlier, homes. The level button, so this pulls out the 4 corners, and the middle, as you guys saw we did earlier. And this is how you're gonna manual level it. And after you do that, you're gonna click on the more. Then you can do the auto leveling and also the fine tuning on the offset there up and down. So yeah, but don't forget to save everything so you can memorize it for next time. And then here we have change, which will change out the filament. So yeah, pretty simple and very well laid out. So back at the menu, we also have the set button, which gives us a file option. And this tells the printer which option you want to use, the micro SD card or the USB. Then you have the continue, which if you had a power outage, you can, continue printing from there. Then our fan speed controls are here about this printer. And we also got a stepper release button, so you can release all the motors. So, and then the last button here is our print button, and that's going to read the micro SD card or the USB thumb drive. So, and even though the screen's not very big, it's quite good on the size of the buttons and very easy to use and read. All right, so let's go ahead and put in some filament, and it does sit way up here and seems to roll pretty good. Okay, so yeah, the filament detector actually does make sense where it's at. It is a little bit hard to get to, but not terrible. And I don't know if you guys can see, but the red light turns into a green light once we go in. And we're gonna go all the way down to the extruder. So yeah, it's gonna go in this little hole here, and then we're gonna compress the arm and push it all the way down in there. And eventually it should be coming out of the hot end, which you guys can see. So it's simple as that, and it's purged, and you don't have to go into the screen and do all that stuff because it's such a short distance here. You can just push it yourself. Looks like we are ready to go. So let's go ahead and grab our thumb drive that came with the printer, and we'll plug it in here. And you guys can see it glows, kind of cool. And then we're gonna click on print, and it looks like there is a test file in there. We can go ahead and click on it, confirm, and it'll start printing. I'm gonna zoom you guys in a little bit closer. All right, so it looks like it probed and now it's waiting. And there it goes. So it's going pretty quick right off the bat. No more. And it seems like it's all good and sticking, or at least what I can see. I'm so surprised how fast it's going on the first layer. It does appear to be a little high though. But the good part is, guys, is that as it's printing, you can push options and then on more, and it has the baby steps that you can adjust on the fly. So I went ahead and pushed it twice to go down. Hopefully it's stuck on there pretty good. But yeah, you can turn your light on and off here. So I just turned it off, on. And you can control your other things here also, like pausing, stopping, changing the filament. Yeah, pretty cool. So here we have the model name, the progress bar, time that passed, the Z offset, which is at 0.9 right now, the nozzle temperature, the bed temperature, and the fan. So yeah, looks like we're off to a good start, and the printer is boogieing along, guys. So I'm gonna go ahead and bring my microphone in. You guys can hear it is pretty quiet overall. Much quieter than most printers. It's a very small, subtle hum, and the fans are all very toned down. So yeah, Artillery is doing a great job here, being quite silent. All right, well, we're gonna let this print out, and we'll see what turns out. So far, I'm very happy how everything is going, and we had no issues. Everything came together well, and everything is working. All right, guys, so our first print is done, and it took 1 hour and 22 minutes. It was printing at 210 on the nozzle and 70 on the bed. Yeah, so the bed is still warm, actually kind of hot. Let's see how easy the print comes off. It should come off pretty easy. It started a little high, but no, look at that. It's stuck super good. So let's see if I force it. Okay, so yeah, it pops right off. if you force it, obviously, but if you wait till it cools off, it should literally just slide off. So yeah, pretty awesome to see that the coating on the build plate works very well. And so this is the print that was printed, and overall it looks really good. It's a little bit on the shinier side, which lets you guys see the layers really good, and for the most part they're all very uniform, so you can kind of see the polygons, I guess. But yeah, as far as the layers are concerned, I think they look really good. So it was printing a little quick. I mean, an hour and 20 minutes for this pretty large print. It's pretty good timing. And this being a test file, I'm not sure exactly, you know, how it was sliced, and our bottom looks pretty good. So yeah, very nice start here for the Sidewinder X2. So I think for the next part, let's jump to the computer and we'll slice our own models real quick. All right, so I got the thumb drive plugged in. Let's see what's inside. Yeah, looks like we only have two things, which is the PDF of the manual, so that's nice, and our test G model there, so that we printed. So yeah, they expect you to download your own slicer, which would be Cura. So let's go ahead and open that up. So if you don't have this program, you just search Cura and it'll come up, and you can download it, and it's free to use in its standard form. So let's go ahead and add a machine. We're gonna click over here. Now if you just download it, it's gonna go straight to this part where you add a machine. So we're gonna add a printer, and we're gonna go to non-network printers, and we're gonna scroll down till we see artillery. And there's two models here, which is the Genius and the Sidewinder. So we're gonna pick the Sidewinder, and if you guys notice, it's the X1, which will be fine. We can go ahead and rename it X2 right here, so no big deal. So we'll click add. So this is our parameters for the printer. Everything looks good. We don't have to do anything here. So we'll click on next. Here we go. So you can kind of see the printer there. It's not the X2, but the main thing here is our build volume, and the build plate is what we'll be working on. So let's quickly go through the settings here, see how they got it set up. So 0.2 on the layer heights, it's good. Wall count 3, infill density 20. I'm gonna change that to 15 to speed things up, but 20 is a good number for general printing. The temperatures 200, that's fine. We'll leave everything at that. 60 on the bed is good, should be good. Print speed, I like to turn that down a bit. Let's say to 50 is usually what I use, especially for this Direct Drive Extruder hot end combo. It's, you know, pretty heavy. So travel speed 150, maybe we'll turn that down to 100. We're not in a hurry when we're traveling. So initial layer here is 20, which I like to turn this down to 15. I usually like to watch the first layer, unless you have an absolutely huge first layer. You know, you can turn this up or down. So, and the brim, I think I'll turn to 20. So yeah, these are all just preferences here, guys. Retraction 2 millimeters. Ew, that doesn't sound like it's enough. I'm gonna change that to 3. We'll see how it does. So 25 on the speed, and all this looks good here. All good here so far. Skirt is usually what I use, and 3 usually is plenty. So yeah, everything else looks really good here. And by the way, if you don't see all these options, if you click on these little menu slots here, you can see that you can choose the different kinds of layout. So I have custom, but if you click on advanced, it'll show you a lot more of the parameters that, you know, we're looking at here pretty much. So all right, so that looks good. Let's go ahead and get that out of the way, and we'll drop in the calibration cube in here. So yeah, it's pretty small for this bed. Click on slice, and there we go. It shows us it's going to be 33 minutes. If we click on preview, you can preview the layers here before you print. So you can mock things up before you actually print them. And here it shows us it's going to take 5 grams of filament, which is 1.5 meters. So now we can click on save here, and it's going to ask us where to save. So since I got the thumb drive plugged in, it's called no name. So you can save that to anywhere you want, obviously, on your computer. And this is our file name, and you can actually rename this anything you want. So we'll just leave it the way it is and click on save. And so now it should be in our thumb drive, which is it is right here. So yeah, simple as that, guys. We're pretty much ready to go. Well, let's go ahead, go back to prepare up here, and we'll right click or double click on Mac, clear the build plate. Also slice a benchy exactly the same way. So the bench is going to take exactly 2 hours and 12 grams of filament. Save, same spot, and that's it. We're ready to go. We got both of our files. And by the way, if you want to manipulate the model, if you click on it, over here on the side you have more options. You can just either grab it here and drag it around, or you can specifically put the parameters in. Same thing for the resizing. You can do whatever you want basically. And then you also got the rotations here. So yeah, pretty basic tools here. But yeah, if you're not familiar with Cura, check out, you know, the reviews on YouTube of how to use it. So yeah, it looks like artillery is part of Cura, which is nice to see. So it's quite simple and easy to slice and start printing. All right, so before we start printing, I want to do a little quick test of how long it takes to heat up. So we'll click here, and I'm going to get my stopwatch out. I'll push start once we get the hot end going. So we'll go 60 on the bed because that's normally where I go, and let's say 210 on the nozzle. So, and you guys can see it kind of is delayed a bit and updating, but so yeah guys, you can see how fast the bed is. It's already at 50s in just 30 seconds. So it's close to 60. So if all this is going to be under a minute, that's going to be mind-blowing. So yeah, you can see the bed is done, and that's 42 seconds about. And the hot end is almost there. Yeah, there it goes. So yeah, under a minute guys, 50 seconds, about 50-55 seconds to heat it up, which is very impressive. And it was slap cold, so yeah, you guys can see how well the AC heating bed works. So another thing guys I was wondering about is, where is the X-axis switch? If we look over here, there's not much going on, and this almost looks like it's part of the bracket here, but in reality, if I bring the hot end over there, there's a little light, you can probably see it maybe underneath that plug that lights up. There's a, looks like an optical kind of sensor in there that conducts with this piece of metal there that is used as the switch. So yeah, I thought that was pretty cool. And also guys, I don't think I mentioned that this is a Titan extruder here. So you can see like there's a bigger gear here, which is turned by a smaller gear that's connected to a motor, and it gives it a lot of leverage. And that's a big plus, you know, to have a really consistent kind of flow. So, and also your adjustability on the tension on this arm here, there's a spring right there. So you just spin this thing one way or the other to force the spring harder this way, which will give it more pressure. So let's go ahead and install our new filament, which is a silky black. That's what I usually use for my testing. So let's go ahead and start the new print. And we can see we got our new files there. The calibration and the benchy. We'll start with the calibration. Confirm. And there we go. And it should start shortly. So yeah, it looks like the slicing is working. Should be going about 15 millimeters a second, not too fast, which is perfect for the first layer. Especially, you know, you want to make sure you're good with the gap between the nozzle and the bed. So yeah, everything's looking good. I'm going to let it print out. I'll also print out the benchy, and then we'll take a closer look at them. All right, so our calibration cube and benchy are finished. So the benchy is still stuck to the plate. So let's look at the calibration cube first. So here we have the X-axis, and you guys can see it turned out really good. There's not much vibration or ghosting, so yeah, that's nice to see. The Y, also not bad, a little bit more vibration and slight ghosting too. But we do have a really large bed, and plus my GoPro is attached to it, so yeah, there's quite a bit of weight there. But so yeah, overall I'd say not bad. Here we have the X wall, the Y wall, the bottom, very nice, and the top looks really good. But it does look very square. We don't have any gaps or anything weird. So, all right. Well, the benchy's still stuck to the plate, and I can already tell that there's some stringing going on. So let's see how easy it comes off. The plate is barely warm. It did cool off a bit. Well, actually, let's check this out here. Okay, it says 38 on the bed. So yeah, it's pretty much cooled off. But what's interesting is that it only took 1 hour and 38 minutes to print out this benchy, even though our slicer said 2 hours. So yeah, the printer is doing it quicker than the slicer is telling us. So yeah. Definitely stuck on there pretty good, but it popped off pretty easy. I'm sure once it cools off all the way, it'll be even easier to pop off. So, all right, so let's see what we're working with here. Yeah, you guys can see the benchy doesn't look all that great, considering it printed faster also, which actually applies to our calibration cube too. So, you know, that might cause a little bit more ringing and vibrations in the prints. But yeah, overall, you guys can see it looks pretty good. There's some inconsistencies. There's something funny going on here, but this part here looks pretty good. Yeah, something happened here. You can see all that stringing, and that's what I was thinking, you know, that the 2 millimeters is definitely not enough, and 3 looks like is not either. So I'm gonna bump that up probably to 5 and see how good it does. So this area here has a lot of retractions, and we can see it looks a little messy, but the back looks pretty good. Same vibrations we saw on the cube. The box looks pretty good, no slit in it. So yeah, I mean, overall pretty good. I wouldn't say, you know, it's great, but that might have something to do with some setting and mostly maybe the retraction, because this is why we see all these little goops everywhere, is because the nozzle wasn't able to retract enough to have a clean print. So before it, you know, moved around here and there, because it does have to move around a lot between this gap here. That's why it probably looks like that. So I might print another benchy just to, you know, see if it's going to be any better with the 5 millimeters. But yeah, I mean, overall, I would say, you know, pretty good. I mean, the cube turned out great considering, you know, it could have been worse, I guess. But yeah, it does appear that the printer is printing faster for some reason. An hour and 40 minutes for a benchy is quite quick. Usually, you know, my benchies are 2.5 to 3 hours. So yeah, I mean, that's like half the time. So I'm pretty sure the benchy would look a lot better if it was printed half the speed. So in any case, everything's working well. The build platform is sticking great. Like, there's no issues at all. Once the filament hits it, it sticks. So I'm gonna go ahead and print more prints. And plus, this being a direct drive, maybe we'll throw some TPU at it and see how it does. All right, so these are all the prints that we printed. Most of the prints turned out great, but some we did have some trouble with, and we'll talk about that as we go through them. So we've seen the first print, the calibration cube. Let's go ahead and take a look at the benchy again, because I did print another one, which I turned down the speed to 40 millimeters a second, and that ended up being closer to the 2 hours. And plus, I made the retractions at 5 millimeters, and as you can see, there's a lot less stringing, or I guess about the same amount of stringing, but just much more finer hairs. So yeah, still lots of hairs, but this print turned out a lot better than the first one. And this is a different filament also. It's more of a matte instead of the glossy. So it does, you know, maybe look a little better because of that, but yeah, you guys can see it's much better. So yeah, this basically showed me that this printer does have an issue somewhat, and that is nozzle oozing. So turning this up to 6 or 7 millimeters might help it, but you know, that's kind of going extreme already for a direct drive extruder. But it also depends very much on the filament, and that's what I noticed on the other prints that I printed. So yeah, I think with some tweaking you can get this where it doesn't string at all, but this is the initial results with just a little bit of adjusting. So yeah, just a quick look here from the original to the new one. A pretty huge difference, guys. So yeah, our stringing is just much thicker on the first one compared to the second one. So I also printed this little frog in the same red as we printed the vase, and this thing turned out really good. When I first saw this finished, I was really impressed. And by the way, guys, everything was printed at 0.2 layer height, 50 millimeters a second, and 200 on the nozzle and 60 on the bed. So yeah, you guys can see this frog just turned out beautiful. And I think the retraction on this one was 5 millimeters also, and you guys can see there's no issue with the stringing. Usually there's stringing, you know, between the eyes here. Nothing at all. I mean, it's very clean. Depending on the filament also, it could string more or less, and you can see every layer individually and it's sitting beautifully. So. And on these little arms here, you can see just a tiny bit of whispers there on the stringing, but again, very minor, beautiful print. So yeah, I was very happy about this, and it's more shiny than usual. So I'm not sure if it's a little hotter or what, but so after the frog here, I did print the shark, and you know, this is kind of cool because it prints with many parts and then it all connects together as it goes up. By the way, guys, the bed works excellent. Like, there's no issues whatsoever with sticking. Actually, it might be sticking a little too good, so, but the models do come off pretty easy when it's cooled off. So yeah, but the shark looks great overall as far as the layers are going down, and all the parts are nicely, you know, working as they're supposed to. But we did have a little mishap here on the tooth. Yeah, and the mouth's supposed to open, but I haven't opened yet. Let's go ahead and try to, and there it goes. So yeah, so we got pretty good accuracy there. So yeah, I would say this little shark turned out nice. All right, so the next one we got here is an octopus, and I did scale it up a bit to make it larger, and this thing turned out really well. And there's a lot of little feet or tentacles that, you know, individually print and then all connect together. And yeah, there was no issues here. It turned out perfect. So really happy about this print. And not only that, guys, you can see how the layers are sitting. They're all very nicely laid down. So yeah, quite good for this printer, as it does put the layers down very consistently. So yeah, another great print here that shows that the bed is very capable of sticking a lot of little parts and then popping off. You know, that could be a big deal depending on what you're printing. And that's definitely one of the strong parts about this printer, is the bed sticks very well. So the next print is for precision testing. And this is a gear that's supposed to move. And this just shows how accurate the printer can put down the filament, so, you know, nothing fuses together. And I cannot turn this by hand. I already tried a bit. It does seem to be somewhat fused, but I haven't tried the wrench yet. So I'm going to go ahead and do that. And we do have some retraction issues in between, a little bit of hairs there. And this is 5 millimeters also. So if I use the wrench, it looks like it's going. Yeah, it is. Okay. All right. Well, that's actually a pretty good, smooth kind of release there. So I'm guessing it's all those little whisper hairs in between that kind of was holding it. And it's actually quite smooth. So let's see if we can spin it by hand now. And yes, we can. So I almost don't feel any kind of bumps or anything. It's quite smooth all the way around. So yeah, very nice. If it wasn't for that retraction, I think we would have a very nice release and it would be perfect, but still very good and acceptable. And you can definitely depend for accuracy on this printer. So here we have a Rook, and this turned out pretty well. The layers are all sitting good. The Sigma here is, I wouldn't say perfect, but it looks decent. There's a little bit of something going on there, but not too bad. The bricks here look really good and detailed. We do have a little bit of layering here and there, very slightly, but you can probably maybe see it, especially on the top there. There's some lines. So yeah, not perfect, but really good. And we got a helix inside there with a staircase. Kind of hard to see, but yeah, nothing weird or blobby in there, or yeah, very nicely laid down. So I did try to print some TPU, and I printed out this Benchy, and it turned out excellent. I was actually very impressed that I thought it almost looked better than PLA. We do have a little bit of filament bleeding here. I didn't clean out the nozzle very good when I transitioned, and you can see a little dark spot here that's still, I guess, affecting that. But yeah, as far as the way the layers went down, maybe you guys can see in the reflections there, very nicely. And I'm using very poor quality TPU here that I got really cheap and ended up being pretty bad batch, but this printer just nailed it and practically made something beautiful out of, number one, terrible filament, and number two, it is pretty hard to print TPU for some printers, but this being a direct drive, it just knocked it out of the park, and everything looks great. Retractions, hangovers, and just beautiful. I did print this using the same file as I did the second Benchy, but I did slow it down to about 70%, so I printed a little slower. TPU prints very nicely on this printer. So the last two prints we got is the astronaut and the spaceship, and these were the two most troubling prints. Let's start with the astronaut, and you guys can see right away this thing does not look good, and it's actually not the printer's fault. This is what a print would look like, or could look like, if you had a bad batch of filament. And what's funny is I've been using this filament for a little bit, and I always was confused why I'm not getting good prints, because it started off okay, but then as I kept printing with it, it just got worse and worse, and now it's just terrible. And I always questioned it, is it the filament? And lately here, as I've been using it, it's been printing terrible. So it's just under extrudes, it blobs everywhere. It's very inconsistent. As you guys saw in the earlier prints, that's not what this printer is putting out. And I set this thing overnight, so I didn't stop it early. So I went ahead and let it print. I can show you guys that not all filament is good and can be just absolute garbage. And I'm going to throw away the rest of it, which is about half a spool left on it. It's just worthless. I tried to print other things with it and it just doesn't ever work right. But if we can take away anything, is if we look here on the bottom, we have very small amounts of surface area that we grabbed to the bed, and there was no issue there. And again, the bed performs very well here. And I guess another thing we can look at here is under the arms here. Usually this is very droopy, but we got very good cooling. So yeah, overall, the printer does do the job as long as you got the right filament. And just to clarify, guys, I do cheap out on my filament, and I usually buy the, what's on sale, the cheapest stuff. But the more I do this, the more I realize that I should probably just pay the extra couple dollars and buy the better filaments. And a lot of times it's actually just the bad batches. So it could happen to any brand, obviously, because a lot of filament comes from the same places. All right, well, for this last print, it was definitely not a filament issue. It looks great, but we do have some gappage here, you guys can probably see. And this is the full 400 tall, and actually this upper portion did very well, but the part that didn't do so well is, for some reason, and when it got to here, the x-axis I guess, wobbled a bit somewhere or was inconsistent somewhere where it, you know, started making gaps as it went around, since this is spiralized mode. And this part here completely fell off as I was handling it, so. And actually, guys, just picking it up, I broke the whole thing in a lot of pieces. So yeah, something didn't go too well here. It was in one piece, it just didn't seem like it stuck so well, and it's kind of brittle and breaks off really easy. But in any case, if we look at the layers, they do sit really nice. We do have some diagonal lines here and there. A little bit of vibration, but not bad, about the typical. The bottom is great. This G usually has a lot of ringing, and there is some there, but not too bad. So yeah, overall very respectable, except for the part that it's not holding together. And you guys can see here on the upper portion where it kind of just printed in the air. So what's interesting is this upper portion here. It actually turned out really nice. And you guys can see the layers went down beautifully. And even more impressive, as we go up here, nothing melted. So we got really good cooling. And the ball also turned out really good. Yeah, I mean, if it wasn't for it basically collapsing here. So I think there's two things for this printer that kind of is not so good. And one thing is the wobble on the top. It is pretty wobbly up there since our spool sits up there. If you have a full kilogram up there, you know, it becomes even more wobbly. Now the good part is physics is on the Sidewinder side, because, you know, most of our weight is doing this. So a lot of our vibrations are kind of going side to side, not, you know, front and rear where the bed is. With that said, as the bed moves around, it still kind of puts a lot of inertia into your table. So if your table is not extremely stable, it'll rock to the top and it'll actually rock it back and forth. So for this printer, consider having a very solid surface that doesn't move easily. And the other thing that was quite obvious on this printer was the leaky nozzle. So for some reason on some of the filaments, they're just more droopy, and that would cause retraction problems. And it seemed like even though you go to 5 millimeters or even higher, which you shouldn't really have to for a direct drive, you know, you're still getting those little whispers there. So not a big deal, because they can easily be cleaned up even with like a heat gun or something. But, you know, I did notice that I did have that issue a little bit. And maybe the only other part is that, you know, this printer here feels quite familiar from the first one, and there wasn't enough changes to kind of make it a lot more different from the first X1. So it is refined, which makes it nice, but there's nothing really revolutionary or different about the newer X2 model. But with that said, it's an excellent machine and does a great job putting the layers down. We do have an excellent bed that's also AC, so heats up very well. The build volume is quite large at 300 by 300 by 400 tall. The Direct Drive Extruder is awesome, especially with TPU. The out of bed leveling probe built in, very nice. It works good. The touchscreen monitor is a little small, but does the job. Love the dual Z axes and the synchronization. The X and Y rails are large, so that's great. And the printer is built very well overall as far as build quality is concerned. And also, not to forget, I love this cable management that they have with the ribbon cables. And also it is very quiet, which is a huge plus there. So I think if you wanted a large format printer, this would be a great choice. And even though there's a lot of options out there, this printer still brings a pretty nice premium feel. Alright guys, well, if you want to pick up this printer for yourself, I'll have some links in the description. Check it out. And if you did enjoy this video, then hit that like button. And if you want to see more videos like this, check out the playlist. You might find some interesting there. And there are more 3D printing videos coming, so stay tuned for that. And as always guys, thanks for watching, and I'll catch you on the next one. Peace.